are three types of streaming. There are three types of streaming. Streaming the stored video. So all these sites like YouTube or any streaming sites, so it may be Netflix or it may be Geo Music or Wink, Savan, all these sites uses one of these three types of streaming methodology. First one is UDP streaming, the second one is HTTP streaming, and the third one is DASH. So this is very important. You may get this for 8 to 10 marks. There are three types of streaming, multimedia data. First one is UDP streaming. The second one is HTTP streaming. And the third one is DASH, where DASH stands for Dynamic Adaptive Streaming over HTTP. Dynamic Adaptive Streaming over HTTP. So now we'll take UDP as an example. First one. See, we have discussed UDP in the transport layer. UDP is an unreliable protocol. We don't have any congestion control mechanism. UDP don't have any retransmission techniques. It don't have flow control mechanism. So it's a very simple protocol, faster protocol. UDP is more suitable for streaming application because of its fastness. So what is the advantage of using UDP in streaming the video? The main advantage is as it is faster, so the server can send a video at the same rate as a consumer can consume it or a client can consume it. Say I started watching the video at particular bandwidth. So I have a particular bandwidth. So if I use UDP, then at my rate only I can receive it from the server, because it don't have any congestion control, connection establishment, flow control, it don't have all those things. No need to check the receiver capacity, no need to adapt some slow start mechanism or any other things for congestion control. And even if the packet is lost, there is no retransmission, and there is we don't have any connection establishment mechanism with the UDP. Because of that, video will be delivered to the client at a very faster rate. So that is the advantage. So in the video, in the UDP based streaming, so the sending rate of the server is same as the receiver side encoding rate, and which is called as constant rate. We call it as CBR protocol. We use something called constant bit rate, CBR, for data transmission. And here, please remember, we don't have any kind of obstacles, and video packets will be delivered at a very high rate. But the thing is, it is unreliable. If the packet is lost, we can't help it. Okay. But there are certain things we need to remember. There are certain limitations of UDP streaming. Some firewalls block UDP packets. So in that case, if let us assume if YouTube uses UDP, YouTube is not using UDP. Suppose if YouTube start using UDP streaming mechanism, so if the firewall blocks the UDP, then by default, YouTube will be blocked by the firewall. So like that, in some cases, firewall, people have written the rules for blocking the UDP packets because you don't have that much security in it. So it will block all the UDP traffic. So if that is the case, if the firewall rule is to block the UDP packets, then we may not receive the videos if the server has adopted UDP streaming. Then the other thing is UDP cannot deliver the video alone. It requires some other protocol help. We call that as RTP protocol, real-time transmission protocol. Okay, we call it as real-time transmission protocol. So RTP protocol help is required. That is one of the disadvantage. One more protocol is required for data delivery. The third one is, so it is unreliable. We may face some errors. We don't have any error recovery mechanism in the UDP. So that is one of the limitation of UDP streaming. So advantage is faster delivery. Disadvantage, so error may occur. We don't have a retransmission mechanism here. Then it requires some other protocol help like a RTP protocol. And in some cases, firewall may block UDP packet. In that case, UDP streaming will fail. UDP streaming will fail. Next, this is the first category of streaming. The second one is HTTP streaming. See, we discussed HTTP in the module 1. HTTP is an application layer protocol. HTTP is an application layer protocol. It works above TCP. So it definitely and completely opposite of UDP streaming. HTTP in turn uses TCP for data transmission. So if you want any packet if you want to start the data communication, you need to establish a connection between the client and the server here. So HTTP uses a port number called 80. So in this case, video will be stored at the server. So there will be a video. So it will be stored at the server. So there will be a buffer. This server irutte. So the client will send a request to the server. Now the server will send the video. So here it uses first connection, TCP will be used, connection will be established from the client to the server by following the three-way handshaking procedure. Once the connection is established, it sends HTTP request message for fetching the video. The server will send the video in the HTTP response message. So we have discussed HTTP request as well as HTTP response in the message formats in the module 1. So obviously, as it is TCP based one, so it follows all the congestion control mechanism, flow control mechanism will be there, and also there will be retransmissions and connection establishment will be there. So it is time consuming, but it is reliable. So how it follows? So there will be a buffer. This buffer is called as application playout buffer. This will be used in the UDP also. So suppose if we are using a YouTube, then there will be a buffer at the browser. Suppose if you have installed YouTube application in your mobile, then there will be a buffer associated with that app, mobile app. So we call this as application playout buffer. Similarly, there will be one more buffer called as TCP buffer. We have discussed this in the transport layer. There will be a buffer in the transport layer. So sender side buffer and the receiver side buffer. So now from the server application layer, the video will be sent to the TCP. So these two establishes a connection. It starts sending at a higher rate. Now, this is the buffering principle. So here, whatever the data you receive, that will be stored in the buffer. It will be at a higher rate. So remember, so the rate at which we receive this video will be higher than the rate at which the application consumes. Suppose you are watching a video, the rate at which you are watching the video will be lesser than the rate at which your device is receiving the video from the server. We call this as buffering. So in the YouTube example, we saw two lines. So this line, the white color line, is the rate at which you are receiving the video. This will be greater than rate at which you are consuming the video or you are watching the video. So this white color one will be at a higher rate than compared to the red color one. So the TCP buffer always receives at a higher rate than compared to application buffer. It is like a red line. This is like a white line in the YouTube. So we start accumulating a video from the server. So we receive more content, but only few content will be sent to the application layer. And very important thing is, as it uses TCP, there will be a congestion control, and because of this congestion control, flow control, retransmission, there will be lot of delay in the data transmission. So that is the disadvantage of HTTP, delay involved in data transmission. But still many server uses this, even YouTube uses this kind of approach, HTTP or some dash will be used. The next one is dash. So because of its reliable features, okay. The main advantage is it can pass through all the firewalls, because no firewall will block the TCP or HTTP packets. Because entire almost majority of the traffic in the entire internet is relying on TCP, so it can't block it. So that is the advantage. Limitation is delay. So that limitation can be overcome by using the buffer at the transport layer. So buffering before watching the video. So by using that, we can overcome it. Then say now we say I am watching the video. Observe here. I will start this video again. Just a minute. So now see here. It is buffering anyway. I started watching. So now I paused here. Done. So first, from my device, this is my client system. I have sent a request to the server. First connection will be established. See, as soon as I type this, see, observe, as soon as I type and enter this URL, first it started buffering. Then I started watching the video. It took just some millisecond or second time. So now I have pressed pause here, pause button. So okay, done. What it will do, first it will send a HTTP request. It started accumulating the video from the server, and I started watching it. Now I have paused it, so it is not receiving the video from the server at a higher rate. Now I want to move to this location. Suddenly I want to move to this location. So this is a 2.26 minutes length video. I want to go to 2.19. Observe. I clicked here. Immediately it moved to that location. Observe, I will show you once again. So see here, till here it has already buffered. I watched it till 0.01 second. I watched it till 1 second. It has buffered till 29 seconds, but I want to move to 2.18 or 2.19 seconds suddenly. We call this as fast forward. So how it happens? When I click here, observe, when I click the cursor, immediately it has moved here, and I start seeing, it takes some delay, and I can see the contents from that location. For this purpose, HTTP has an advantage. It follows something called header, HTTP get byte range. So we call it as byte range header. So in the first module, we discussed about the HTTP protocol. So in that, we discussed the message format also. From the second line in the message format, we have headers like host name, all those things. One of the header name is HTTP byte range. So here, as soon as I scrolled to a location called 2.19, ನಾನು ಇಲ್ಲಿ ಮೂವ್ ಆದ ತಕ್ಷಣ it will send one more HTTP request. Just start sending the data from this point, byte range. ಇಲ್ಲಿಂದ start ಮಾಡು. From this location you start sending the video, like that it will send a request. That is the advantage. Till even though it was buffered till this location, so it won't fetch the remaining old content. It will start fetching the content from the new location, whatever you have specified. So because of that, fast forward and also rewind is possible with the HTTP. Ilkotru saha, again new HTTP request will be sent from this location. You start receiving and you can watch it. So buffer ಅಲ್ಲಿ ಇಲ್ಲಿಂದ load ಮಾಡಕ್ ಶುರು ಮಾಡಿ. It start loading from this location. If you move to this, it start loading from this location. So that is HTTP streaming. Any doubt till here?
No, sir.
Okay. The last one is dash. We call this as dynamic adaptive streaming over HTTP. What is this dynamic adaptive streaming over HTTP? It is an extended version of HTTP based streaming. It uses HTTP only, and also it uses TCP for TCP at the transport layer. But the advantage here is the server will maintain, suppose if a video is there, server will maintain different versions of the same video. Server will maintain different versions of the same video. We saw a DNS video now. So server will maintain 4 to 5 copies of DNS video. Each copy is of different version. What is the version here? Low bandwidth video, medium bandwidth video, like that. Low resolution video, high resolution video, medium resolution video, like that. Different video versions of same video will be maintained at the server. So divide video file into multiple chunks. So each chunks are stored and encoded at the different rates. So server maintain different versions of same video. Low bandwidth or low resolution video, high bandwidth, high resolution video, like that. Also it maintains a file called manifest file. Also the server will maintain a file called manifest file. What is this manifest file? This manifest file will have a technical information of all the stored videos. First, client will send a request for the manifest file. It won't receive the exact video first. Server will send a manifest file. Client will came to know that at the server, okay, so for this video there are 4 versions. One is if this resolution, second one is of the other resolution, third one is high resolution, fourth one is very high resolution. Currently my bandwidth is this, so I am getting the data at this bandwidth, so it is very low. Let me request for low resolution chunk. So it requests for a low resolution packet from the server. So when I get the low resolution packet, suppose by that time, if the bandwidth has increased dynamically, if the bandwidth has increased, then what it will do? Server client will send a request for high resolution video. User will not do this. The client will do that. It may be the app what you have installed or your browser will do that. According to the situation, according to the current bandwidth level, it may request a particular resolution video from the server. So dynamically it will adapt. Dynamically it will adapt the resolution of the video. That's why we call it as dynamic adaptive streaming over HTTP. If I don't have a high bandwidth internet connection, then I will request for a low resolution video. If I have more bandwidth, then I will go with high resolution video. That is dash. So based on my bandwidth availability, dynamically I will adapt the resolution of the video. That's why we call it as dynamic adaptive streaming over HTTP. So any doubt in this? Here client is an intelligent device. Client is an intelligent device. So it know when to request a chunk. So it takes the decision. Suppose if the buffer space is not available, it won't request. If the buffer space is there, then it will request. If buffer is starving for a space, if starvation is there, then it won't request for a chunk. If it is fine, then if overflow does not occur, if everything is proper, then it will request for a chunk. Then also it follows encoding rate. So if the bandwidth is less, it follow lower encoding rate. So it requests for a low resolution. If bandwidth is high, then it will increase the encoding rate also. Then where to request the chunk? So everything will be decided dynamically based on the situation. That's why we call it